Hi everyone, today we're looking at an O-level question that touches a lot on the volume of solids, in particular volume of cone and volume of cylinder. And so let's jump right in. Diagram 1 shows a thin metal in the form of a sector of a circle of radius 20 cm. So we see right here, 20 cm is our radius. And angle AOB is 120 degrees. Sure, so we see that over here. And this metal is then bent to form a right circular cone. That means when we bend this, when we bend this shape in diagram 1, we actually get what we have in diagram 2, which is a cone. And I know it's hard to visualize. Actually, what you can really search up, let's search up on YouTube, how to make a cone. And if you do that, I think you'll definitely find good examples on YouTube on people who have done this example. And they will fold it and then bend it, and you will see that it does make a cone. Right, so let's jump into part I. Part I, convert 120 degrees to radian. If you're like me, I don't like to memorize things. I just want to know the key concept. So what do I know about degrees and radians? I know that 360 degrees equals to 2 pi radians. Right, so this one you can memorize. 2 pi radians is one full circle, and 360 degrees is one full circle, one full round. And I want 120 degrees eventually, so I can write down here 120 degrees equals to how many radians? And the rest is actually just ratio. And so from here, since I want to get 120 degrees, why don't I just find 1 degree first? I do this by dividing it by 360. On the right hand side, what I do also is I take 2 pi and I also divide it by 360. So that's the first step. On both sides, you divide by 360. And then you want to get 120 degrees, so you multiply by 120. So this one you also multiply by 120. And then what you get over here is simply, this would be 2 pi over 360 multiplied by 120. And you go key that into your calculator, and you will find that you will get 2 pi over 3 radians, or 2.09 radians. So I'll just write over here 2.09 radians. Part double I. Find the length of this arc APB. So straight away, let's just look at it. APB, what is this length? Oops. So length of an arc actually really is this. APB. This is the arc of a circle, and we're trying to find this length. That's what we're trying to find. For this one, what you need is the formula for any given circle, that for a circle of radius r, if you have this arc length, let's just highlight it like this. If you're on this arc length, and then this will be this span with the angle theta. This is r, the radius. Then this arc length, let's call it s. The arc length s is equal to r times theta, with the catch that theta must be in radians, not degrees. It must be in radians. So in this case, we look at APB. Let's look at this formula. Look at APB. What do we want? We want APB, and so what we need is this angle. Do you agree? And so we already found that this angle below here is 120 degrees, which is actually 2.09 radians. So what we can do is, we know a full circle is 2 pi radians. So what we can do is we can say that the angle, the yellow angle, is actually 2 pi minus 2.09, because one full circle is 2 pi, right? And then we are subtracting away 2.09 radians, which is the 120 degrees. What's left is the angle in yellow, which is 4.19319, and of course it goes on for forever, I think. I'll just leave it to 5 dp for now. I just want to make sure I don't get any rounding off errors. And so that is the angle in radians, right? So I can write it here. This is 4.19319 radians. and I want to find my arc length. And so my arc length, if I look at the formula again, is given by r theta. So it's given by r. What is r? R is 20 degrees. 4.19319 radians. And this gives me 83.775 cm, or if I round it off, it's 83.8 3SF. So let me just write that down. Cool. Now we want to find the volume of the cone in part III. So let's just write down what we know about the volume of a cone. For a volume of a cone of this radius r for the circle on top and vertical height of h, we know the volume is equal, let me just write it below, volume is equal to 1 over 3 pi r square h. And so we look here, do we know what r is? Let's just label it. Do we know what r is? Yeah, and it doesn't seem that we really know that right now. And then we also ask ourselves, do we know what h is? Now h is the vertical height. Do we know what h is? Okay, let's try to study it a bit more. Let me erase the part from the writings from the previous part so that I can illustrate some things more clearly. So from diagram 1 to diagram 2, how are the sides related? Let me just show you. This 20 cm is actually the slant height. And this whole part, this whole arc length, that actually we solved. What was it? From the previous part, we actually solved that the arc length was 83 let's write the 5SF version, 83.775 cm. So this is actually 83.775 cm. Yeah, and that is actually this whole thing. It's hard to visualize, so what I really recommend is go and search up on YouTube how to make a cone, and just look at someone, or you can cut it out yourself and just find a video of someone folding something from diagram 1, and you'll see that it does give you what you have in diagram 2. Yep. Okay, and so let's try to apply that now. We're going to find the volume of the cone. Let's try to find r first. Let's try to find this r first. Okay, let's think about it. We have the slant height. Oh wait, hold on. What we can do is, because we already know that this whole length is 83.775 cm, that means the circumference of this circle is the same. It's 83.775 cm. So we can say that 2 pi r, where this r is actually this r, right? And that is actually equal to 83.775 cm. Yeah, that's pretty neat, right? And then we can just solve for r, and that r is simply 13.333 cm. Good. And so there we have it. And now let's try to find the height. Okay. So it seems, can you see that we have some sort of a right angle triangle here? We do have a right angle triangle here. And so for this right angle triangle, let me draw it here. This slant length over here is the same as this. That's what I told you. So that is actually 20 cm. R, we solved it. This R is 13.333 cm. And this is the height that we are trying to find. We can apply Pythagoras theorem. Yep. So we can say that height square plus 13.333 square equals to 20 square, or that h square equals to 20 square minus 13.333 square and h equals to the square root of this entire thing, and h is therefore equal to 14.907 cm, to 5 SF. Alright, finally we are ready to apply the formula. So let's just look at what we have. We have the h that we wanted. This h is basically this h, and we wanted this r, right? This r square. I mean, we will square it later, and we solved it here. Now we apply. Okay, pardon, I've run out of space. Oops. So this final volume of the cone is 1/3 pi r 13.333 r pi r square multiplied by h. There you go. Key it all in. What you get is 2775.074 in 3dp, and then let's just make it 3SF in the O-level way. There you go. 2780. Let me zoom out so you can take a look. Alright, so let's go to part B now. The diagram below shows a container which is made by attaching a hollow hemisphere of internal radius 23 cm. So we can see it over here, 23 cm. And to the rim of a hollow cylinder with the same internal radius h cm. And the container is suspended by O, from O by 4 wires, these 4 wires, each of length 36 cm. And they're fastened symmetrically to the rim of the cylinder. Okay, so it's fastened over these 4 points. Given that 43.7 liters of water is needed to completely fill the container, find H. So what it means is that I pour water in, so let's say I fill water in, right, and then I fill it all the way up. And the volume of water is basically, if you can break it apart in your mind, is made up of the volume of this hemisphere plus the volume of this cylinder. Right? No water. This is suspended, so that there's no water there. There's no water outside. Yep. Okay, so first step, we look at 43.7 liters of water. So what we have to do, actually, we don't like liters. All this is in cm. So actually, we have to know this fact that 1 liter is actually equals to 1,000 cm cube. And so 43.7 liters is simply 43.7 times 1,000, which is 43700 cm cube. Yep. So when you look at this, you should just think now in your mind, this is 43700 cm cube. Yep. Alright, so now let's try to find the volume. So the volume of the hemisphere, is given by, the volume is given by 2/3 pi r cube, where this is r. And so when we plug it in, what we get is 2/3 pi is 23 and cube. Yep. And then we want the volume of the cylinder. And so the volume of the cylinder is actually, of course, this is for IH and the radius r. And you can see that these two r's are the same, right? From this diagram, they are the same. And so the volume, this volume of the cylinder is actually, so actually let's call this volume of hemisphere, and this one's volume of the cylinder. And this is equal to pi r square h, or let's substitute it in, pi r square. Do we know what h is? We don't know what h is, but we're trying to solve for it. And you can see that the volume of this hemisphere plus the volume of this cylinder. What they're saying is that it equals to 43700 cm cube. Yep. So let's just plug it in. So this is 2 over 3 pi 23 cube plus pi 23 square height equals to. Then you solve it. So that gives me pi equals to 43700 minus 2 over 3. This is a cube. And then when you solve, you get h equals to 10.96 cm, or if we can try to make it 3SF, 11.0. There you go. All right, and so that was a pretty crazy question. So I'm going to zoom out here and take a look at the whole thing at once.